My name is Jiang, and I'm a grad student at the University of Alabama. My topic today is multi-agent-based wireless sensor, FPGA sensor network for multi-agent tracking and calibration. In this work, I use pyroelectric sensors, but our research is not based on the PI sensor. In our lab, we have motion sensor, thermal sensor, acoustic sensor, photonic sensor, and pressure. The motion sensor we use for visualization, and the rest of the four sensors we use the so-called binary sensing system, which is low cost, low power consumption, and low data throughput. And we also designed some reconfigurable board. This is the sensor board, thermal sensor board actually, and this is the power management board. And the power management board usually work with the FPGA board. Here, the FPGA board, and in the middle, this is the acoustic and arc detector board, and this is this one is the optic fiber receiver board. So the questions are: we have so many different kind of sensing modalities, and we have different computing platforms like PSOC, which is programmable technology. This is on the backside of the sensor board, and also FPGA board, and FPGA, and some stuff like mobile device. So how you want to make how can you make everything work together? That's a big challenge. Also, we also need to think about the complexity of human activity. For instance, the first time I make my system work, I let my professor test it, and he's like working fast and slow, and rotate and stand still and make some arbitrary random work. I would think like, our professor takes it easy, and you are torturing my system. Like, this is research. We have to deal with lots of situations, so we have to consider the complexity of human activity. To integrate them, we propose the multi-agent system. An agent is an individual unit that can work by itself or work with other agents. So that makes sense. You can add and remove agents without losing the ability of the system. So we also provide the context awareness and group awareness to make the system robust. Now the system looks like this. We have sensing agents powered by the indoor solar panel, and the action agents and some other agents, and the decision agents here collect the binary data from sensing and action agents, and maybe some other information from context awareness. And then the decision agents make decisions like the location and the identification of the target, and the calibration parameters, and all this information will be stored in the database agent. So the users can also interact with the multi-agent system by just choosing different policies. For example, if the user chooses the QX policy, oriented policy, the system, the context awareness information will be added, and also the sampling rate of the sensing agents and the action agents will be increased, and maybe some other agents, sensing agents will be triggered to improve the quality of service. Let's take a look at some of our components. This is the Sensor-Actuator Units. As you can see, two guys standing there talking in the room, and the motor here can control rotate the sensor to detect them. This usually works with the context information. If like the sensor cannot no longer detect the signal, and the context information will tell the sensor that these two targets actually are still there because the last time updated location information is far away from the entrance, so the motor will do the work. And the next one is the FPGA unit. The FPGA unit is the most of the work of computing. Here you can see the 3 layers FPGA unit, the transceiver layer FPGA board, and the power management board. And the digital analyzer shows the I2C slave we programmed in the FPGA. Now the database agent. The database plays a central role in our multi-agent system. So we have 3 categories of data, different kinds of data. And the target information, sensor information, and the situation information. The users can use laptop, tablets, and PC to access the data, to read the information or change some parameters. Now, as you can see, this is our system setup. There are some sensor agents and action agent here, and decision agents and the database agent plots will be displayed on these 2 big screens. And also, I need to mention the optical fiber down the pad, which gives us the branches of checking. We also built the mobile calibration tools to make the users doing calibration easily. Like here, the 2 pictures show that the users can calibrate with their own way. And now this calibration, when the more you do the calibration, actually the better the checking result will be. And the Kinect motion capture sensor, we use Kinect motion capture sensor to create the stick model of the of subjects. And the Kinect motion capture sensor is the vivid visualization for users. Now let's take some time to it starts automatically. Okay, this is the one target tracking demo. The target is working actually exactly as you can see, and the users can control the tracking system by just push some buttons. That's why you see the subject is carrying the tablet. So. Time. Okay, this is the 2 target case. These 2 targets, these 2 subjects are working a circle way. A circle way. After a while, the system will tell that this is a working scenario, and after a while, the system recognizes the 2 target case, and then when the tracking is stable, as you can see, the 2 targets are recognized. Now, so in this case, I use only 12 bits to achieve 2 target check. I have to say the resolution is not so good, but it still can work very well actually. I would like to thank my colleagues, Mr. Rima, and my wife Jiang to help me, and my sponsor SF. Thank you so much. That's all my research.